The secondary side of the substation transformer is connected to a substation bus. The substation bus supplies distribution voltage to distribution feeders. A feeder is made up of a number of wires that carry electrical energy at primary distribution voltage from the substation into a service area. In most systems, primary distribution voltage originates as three-phase power. Feeders, sometimes called primary mains or mains, consist of three individual wires that are buried in the ground or strung overhead on utility poles. Each one of these wires carries one phase of a three-phase feeder. Depending on the type of system that a company uses, a fourth wire, called a neutral, may also be part of the primary feeder. In this example, the neutral wire is located at a lower point on the pole than the three-phase wires. In the simplest of distribution systems, a customer is supplied with electricity from a distribution transformer connected to a feeder. The transformer receives electricity at a primary distribution voltage through a wire tapped off of a feeder. The transformer steps down the primary voltage to a secondary or utilization voltage, which a customer can use. Wires passing through the bushings on the secondary side of the distribution transformer form a secondary bus, which supplies secondary voltage to a consumer by way of a service drop. This simplified diagram represents a portion of a distribution system that supplies a service area. Here is the transmission line coming into the substation. Here's the substation transformer and the substation bus. These solid lines are three individual three-phase feeders. To keep our diagram simple, we're showing each feeder as a solid line. But keep in mind that each feeder is normally made up of three individual phase wires plus a neutral. Now, this substation supplies electricity to all of the customers within this service area. Typically, these customers include residential communities, industrial facilities, and office buildings located in various regions of the service area, which can be several miles apart. To reach customers in specific regions of a service area, laterals are tapped off the feeder. Laterals are nothing more than extensions of feeders that supply electricity at primary distribution voltage to regions of the service area that are not adjacent to the feeder. Connected to the laterals are distribution transformers with service drops supplying customers with electricity. In this simplified diagram, we're only showing one transformer on each lateral. In an actual system where the laterals extend for several miles, there may be numerous transformers on each lateral, as well as on the primary feeder. This type of layout is called a radial because the laterals radiate from the feeder to specific regions of the service area. Other layouts are also used. These include the loop and the duplicate supply. In a loop design, the lateral coming off the feeder runs through a region of the service area and has the capability of rejoining the feeder farther down the line. This is very common in residential communities that are supplied by underground systems. The lateral is connected to the feeder at one end by a fuse. At the other end of the lateral, there is also a fuse. This connection is often left open. With this type of layout, power can be supplied from either direction, depending on which fuse is opened and which fuse is closed. Loop systems are very flexible, and they provide a good deal of protection against long outages. If there's a problem on the lateral, service can be restored to the majority of customers on the loop simply by connecting the open fuse and disconnecting the closed fuse. The final type of layout we'll discuss is a duplicate supply, sometimes called a spot network. This type of layout is often used to supply hospitals and other urgent need customers who cannot tolerate a loss of service. A duplicate supply system is supplied by two separate feeders. It works like this. Taps from two feeders run to separate distribution transformers. One transformer is connected to one feeder, and the other transformer is connected to a second feeder. The secondary side of each transformer is connected to a secondary bus. From the bus, a service drop supplies electricity to the customer, in this case a hospital. Between the bus and each transformer is a protective relay. Under normal circumstances, both relays are closed. The secondary bus is then supplied with electricity from both feeders. However, if a problem develops, for example, with this feeder, this relay will open automatically. The bus is now being supplied from the feeder connected to this transformer. Even when there is a problem with the system, the hospital will experience no loss in service. As we indicated earlier, there are many different ways to lay out a distribution system. However, in most cases, the layouts will be variations on the radial, the loop, or the duplicate supply that we've shown you here.